Okay, we're now moving on to chapter 8, which is critical path analysis. So, straight away, we'll just skip on to example 2. Example 2 gives us what's called a precedence table. And a precedence table just gives you the idea of the order in which an activity must be completed. And critical path analysis is often like project management. So it's about deciding which jobs get done in what order, what jobs depend on what other jobs. So do you have to do job B before doing job C, for example? And then it's about assigning workers to those jobs to complete the job in as quick a time or a few as workers as possible, depending on what the problem is asking you to do. So it's an example of what a precedence table actually looks like. So it says activities A and B do not depend on other activities. So you could get your first two workers to get cracking on those two. Just put a dash on those because they don't depend on anything else. Both activities C and D can only be started once activity A has been completed. So both C and D depend on activity A. It then says activity E cannot be started until activity B has been completed. And activity F cannot be started until activity C and E have been completed. Activity G can only be completed once all activities have been completed. Now, a good tip for you if you are ever having to complete a precedence table is the depends on column will need to contain every letter in the left-hand column in every activity. So just count them off and you've got A, B, C, D's missing, E, F's missing, G's missing. So those activities were missing from our precedence table. Okay. Well, obviously not G. G doesn't depend on G being completed, that's a bit daft, so it's just D and F. So what we can then do is draw what's called an activity network. An activity network just displays this information in a diagram. So you have what's called the starting node, or source node. And then we say we can get cracking with activities A and B. And these nodes represent events. So this event here is that A has been completed. This event here is that B has been completed. So the nodes represent events, the arcs represent activities. Now you can number the events, so you can have 0, 1, 2 and so on. You don't have to though, there's nothing to say that you have to do that. It just sometimes helps with your identifying. So you could say what activity links events 3 and 4, for example. Okay, so then it says both C and D depend upon A having been completed. So if I do D there, C there, because C and D must take place once A has been completed. So event A has been completed, we can get cracking on with C and D. Event E can take place once B has been completed. But if we look down here, you'll see that you need, before you can do activity F, C and E have been completed. So we need C and E to come together. Well, there's C. If I do E in this direction, so it joins up with C. So then we've got an event here that C and E have been completed. So then we can get cracking on with F, and then you'll notice that G is that D and F have been completed, so we need D and F to come together. So this event now is that D and F have been completed, in which case you can get cracking on with G, and you must end your project with what's called the sync node. Okay, and that's what an activity network would look like for this precedence table. literally everything you need to have a go at exercise 8A now.